So this talk, I just want to encourage people that continuous delivery is a journey. And to me, I mean, you really never finish. But I can say that if there's not a button that somebody in your organization can push right now to deploy the latest thing that's passed all your tests, then you don't have continuous delivery yet. Okay, you might have really good automated build and test, but not quite CD yet. So who am I and why am I so opinionated? So I'm Ken. I'm a technology evangelist with ThoughtWorks. I've been with the company for about 8.5 years, mostly doing continuous delivery stuff. I'm actually one of the DevOpsDays core organizers, so I think this is 27 DevOpsDays for me. Nobody can spell my name, so I went and grabbed ken.wtf if you want to see a blog that's very rarely updated. Stole that from Pete Cheslock, I admit it. Sorry, Pete. But anyway, there's some information there on background and why you can think that. Now, as I mentioned, I'm really big on agreeing on definitions of words. And so I want to start with a couple definitions. When I say DevOps, this is what I mean. Okay? That doesn't mean that this has to be what you mean. But for the rest of this talk, if we talk in open spaces, if we talk in another event, if you read a blog or what have you, when I say DevOps, that's what I mean. I think it's important in your organization that you also agree on what these things mean. Because if you say, oh, I did A, and someone said, oh, cool, but they're actually expecting B, that's going to be a problem. For me, an easy test for the word DevOps is to, like you can do with any synonym, switch out a synonym in a sentence, see if the sentence makes more sense. So for me, switch DevOps with culture. And I apologize, because I know there's people in this room that have a job title that probably says DevOps engineer. Not a big fan of the title, because to me it means culture engineer. And that's unlikely to be true. So, that's that rant. Continuous delivery. This is the definition I most likely use. This was written by an ex-colleague by the name of Jez Humble. He wrote the book called Continuous Delivery with a gentleman by the name of Dave Farley, so I think that this is probably pretty safe. The DevOps one I made up. This is from the author. Okay, so why this talk? So as I mentioned, I've been with ThoughtWorks about 8.5 years, and we're mostly a consulting company, and so I get to see a lot of implementations. And people say, yeah, I'm doing continuous delivery. I just have to give it to the security team. I just have to run that test. I just have to run it by the change management board, et cetera. And that's cool, but it's not CD. And so I'm like, no, not quite. You might be doing a really good automated build and test, but let's talk more about this. Now, for a DevOpsDays audience, the following might be a lot of repetition, but I'll want to set baselines. And so, why should you do continuous delivery at all? Where did the name come from? It's kind of interesting. Jez and a guy by the name of David Farley were writing a book called Continuous Delivery, and they were saying, what's the title of the book going to be? And our chief scientist is a gentleman by the name of Martin Fowler, and he pointed them to the second page of the Agile Manifesto. So if you're familiar with the Agile Manifesto, it's we value this over that, etc. Hardly anybody turns to page 2, where it's the principles behind the Agile Manifesto. And the first one talks about the continuous delivery of valuable software. And so that's why they use the term continuous delivery. It's really the missing piece, if you will, from Agile. Agile, we were building the thing and then handing it off, and then 6 months later it showed up in production. Anybody done Agile 101 training? Probably 10, 15 years ago. Remember this slide? The other reason for continuous delivery is that partially done might actually be useful. Okay, so that's not particularly useful, but that might be. Okay, so if you take these practices, if you could deploy to production right now, then you could run tests with your customers and say, am I going down the right track with this feature? Okay, it doesn't mean you're not done yet. The other reason, another reason, respond to security threats. The hackers aren't going away. It's scary that this is what Heartbleed was, 2.5 years ago, something like that? 6 months ago, you could still find a lot of systems that had this. Not because people are lazy, but because people couldn't update their systems. They didn't have the automation. If they updated that version of OpenSSL, something would stop working, etc. So this automation, people that had, I guarantee Amazon was updated within 12 seconds. I mean, it might be a little bit of an exaggeration. But having a pipeline where you can deploy at any time makes it so that when you have to react to something, you can react to this. Anybody familiar with Knight Capital? Oh, good. We'll get back to Night Capital. Okay, so we want to be able to deploy at any time. To deploy at any time, to practice continuous delivery, you must have solid continuous integration. Full stop. Okay, the purpose of a continuous delivery pipeline is to kill a release candidate. Every time I commit code, that's a release candidate. I can't prove it's good. I can absolutely prove it's bad. Okay, so the pipeline's job is to say, nope, not good enough. Didn't pass that regression test. Didn't have this thing that we need in compliance. Didn't pass the security test. That's the pipeline's job. You can't do that if you don't have good testing, and CI is a very important part of good testing. Okay, so don't skip this part. ThoughtWorks is a thing called Tech Radar where we espouse our opinions and pretend other people should pay attention. And we came up with this thing called CI Theater. What this is people saying, yep, I'm doing continuous integration. There's my unit tests. It's like, okay, but you're not really testing very much. You have unit tests, but okay. The one that really scared me the most, only 10% of participants said having a tool is different than doing the thing. Okay, I work for a tool vendor. Feel free to download our tool. It will not give you continuous delivery. Okay, you still have to do the thing. It's scary to me that 9 out of 10 people said, yep, we're doing CI, we got the tool. Not the same thing. Please do the work. Now, when we say do the thing, continuous integration, we have some very specific things. I'm not going to do what Jez and Dave do. They make people raise their hand and so forth. But this is our definition of continuous integration. Every single person, every single change, pushing to trunk, master, whatever you want to call it, every single day. No long-lived feature branches. I'll go into that in a second. Every single commit triggers your tests. It's not nightly, it's not weekly, it's every single commit. And then the last one, this is the one that hardly anybody does. If it's broken, generally it's fixed within about 10 minutes. Okay, your server being red all the time, there's nothing wrong with your server going red. Okay, that's its job, is to prove something is bad. Please don't do the dunce cap or whatever for broken builds. Okay, you're supposed to push the envelope, the server's there to protect you. Okay, but when it is broken, you need to fix it. Flaky tests and that kind of stuff, just make it so you don't trust your server anymore. They don't, can I click the button? Well, I don't know, that thing's always red. Yeah, it's red because of the network. Is it, or is it red because the security test failed this time? Okay, so fix your builds, please. The one that generally does the most controversy about this is the feature branch thing. It's not that you can't do really, really, really good automated build and test using feature branches. You absolutely can. We would just say it's not CI from a definition perspective. Okay, why do we say that? So stolen off of a blog from Martin Feller from 2009. So here we have a couple developers. We have Professor Plum and Reverend Green, and they're writing code. Okay, and Professor Plum, she's working along and doing her things, and okay, somebody did a bug fix in mainline, so going to do a git pull and put that in her branch, and she's working on it and so forth. And then Reverend Green's working on his branch, and he's going to do a pull, and they're all working on everything, and everything's cool. And now it's a race, okay? And Professor Plum finishes first. She's done with her feature, and it goes to mainline. Now Reverend Green has to do a pull. Oh boy. Okay, so the technical term for that is big ball of mud. We've all had this. You get the massive merge conflict. Okay, there are really, really good tools for fixing this. So no big deal, right? The problem is that merge conflict tools are only looking at the textual differences, not the conceptual differences. So what if we changed our intent? What if we changed meters to feet and now the Mars thing crashes into the planet? That didn't actually happen because of a feature branch, but it did actually happen. So this is why we don't like feature branching. We want to test every single thing, every single time. If you go to the blog, it's a whole lot more detail on that. By the way, I'm going to go high level on a lot of things. The purpose of this talk is to get you to go learn more about it or ask us later or what have you. So on that note, pipelines you should be including but probably are not. As I mentioned, I've seen a lot of continuous delivery instances, setups, etc. It's incredibly rare that I see real security testing. Now, I'm not a person that says automate all the things, that cliche buzzword, whatever you want to call it. Because there are things that you can't automate. Okay, I have a good friend of mine that sits in a room and hacks on systems, and he's going to find stuff that you'll never know he could find. And I want Jason. Jason's a valuable person, okay? So I'm not saying you can automate all the stuff, but there are a lot of things that you can automate. And the manual stuff can be out of band. He doesn't have to finish his set of manual things every time we're going to do a release. Okay, he can be going on a thing, and when he finds a thing, it's an issue, and that issue gets prioritized with the rest of the work, depending on how vital it is, right? This is something I, again, almost never see. There's tests that you can run as pre-commit or pre-push hooks, like looking for secrets. And these don't have to be very specific. These can be regular expressions. Is there a thing in here that matches what does look like a key for Amazon? Okay, I don't want that to get into GitHub. If that gets into GitHub for milliseconds, it's dead. You have to kill it. There's people watching those triggers. Okay, so there's tests you can put on pre-commit. So git push. Nope, this looks like a key. Okay, we wrote a tool called Talisman for it. If it's open source, you can go look for it on GitHub if you'd like. Static application security, just like code review kind of stuff, okay? There's tools out there, like if you're doing Ruby, there's one called Brakeman, and there's Sonatype does some stuff for Java and Nexus and that kind of thing. Sonatype actually did a study that the average Maven Central project, so Maven Central, if anyone's not a Java developer, you say Maven build, it downloads the internet, and then builds your thing. On average, they do like 126 components as the average Java application according to their statistics. And more than 20% of them have known vulnerabilities that have been fixed in later releases. But in the Maven configuration file, people call for a specific version and it's not secure. Okay, so there's ways you can test for that. So do. Dynamic application security testing. Know my child's name is not first name, parentheses, colon, drop table, users, colon. Okay, if you're not watching for SQL injections, that will work. Okay, you can test those things, and that should be part of your pipeline every single time. Because you don't want to go back and have to fix a month's worth of code because you only ran your security test when you thought you were ready to release. Performance testing. Anybody here in retail? This is where we say winter is coming. So you got to do my Game of Thrones thing. It's amazing the difference performance makes on how long people will spend on your site or if they're going to buy your thing. It's measured in milliseconds. If people come there and they're looking at the thing and it takes too long to load, they're gone. They can get that plane reservation somewhere else. Okay, they can buy that TV somewhere else. You have to watch these. And again, they're really hard to fix later. If I have to look at a month's code to find my performance problem, that's hard. Okay. So you should be doing load testing. You should know what's the maximum capacity, your expected capacity, sorry. I expect to have this many sessions. I want to load test to make sure what the response times are at this load. If you are a retailer, you want some stress testing. You want to throw a bunch of stuff on it and see if it breaks. So ramp up your users and see where it crashes. Oops, need more auto-scaling there. I don't want to do a Pokemon Go. Nobody does this in pipelines. We're all a little bit infatuated with the idea of, I can get to production in 3 minutes. Okay, it's important that you have a way to get to production in 3 minutes if you have like a bad security problem or whatever, but other than that, that's not a thing. There's very few of our applications that we really need to deploy that fast. Okay, so set up a test that runs it for hours or days. See if you have any memory leaks. Okay, see if anything comes up. And then spike testing, just throw a bunch of stuff at it, see what happens. Now I should say, I mentioned, there does need to be a way to get things out faster. So run these things in parallel. Any of the modern tools, and so I'm not going to say, we've got to have ours. No. Any of the modern tools can do this. I can say, like in this particular diagram, I want to run my functional test, load test, spike test. Those are all going to run on every time the thing builds. And if any of those fails, then I'm not going to allow a deployment to staging. Because I don't want things that are, why? It's a waste of resources. Fatal functional test, there's no reason to put it on staging. But I have things down there, stress tests, et cetera, that take much longer to go. Okay, the purpose of a staging environment is to test the deployment. That's why it's important that your staging matches what production looks like. It doesn't have to match exactly. If you're a large enterprise and you have 1,000 servers in production, you don't have to have 1,000 servers of staging, but you do have to have the same kind of cluster and the same kind of database connections and the same kind of networking. But the purpose of deploying to a staging server is to test that deployment. Now, full disclosure, if our company had had a good staging server on a project in London in 2006, the continuous delivery book would not exist. They were writing a Java application. The developers had Windows laptops. The deployment target was Solaris. Okay, because we all know Java runs the same everywhere, right? Yeah. So they spent months writing this application, waiting for procurement to get the Solaris box. They finally got a Solaris box, they deployed to it, it did not work. And I don't mean some tests failed, it wouldn't start. There were some things they were doing with Disk.io that don't work with NFS. So they went and got an old Sun workstation, brought it in, wrote a bunch of bash scripts, called it Conan the Deployer, real story. And then the people on that project, Jez Humble, Sam Newman, Dan North, Chris Reed, did a white paper called the Software Production Line, and that's where the book came from. That would not have existed if they had had a real staging server. It bit us hard. Now this is a simplistic diagram, but it could get a whole lot more complicated. This is a real one. So in reality, our products, our projects, our software has multiple inputs. There's lots of Git repos going on. They're writing tests, they're writing deployment scripts, et cetera, et cetera, et cetera. You can do these things in parallel where it makes sense. And just make sure you go whatever way makes sense for you. Speaking of makes sense for you, you should decide the order that these pipelines run in. Okay, so this is a real screenshot. I don't know if you can read that, but the top right one up there is a performance testing pipeline. Notice that's at the very end. It's after upload installers. It's after the analytics plugins for this particular product. So we don't want to spend the money to run a performance test unless all the other stuff is gone, because this is really expensive. But at that point, again, it's still a release candidate. So these performance tests will be run before it gets released. So deployed is put on the server. Released is made available to the people. Okay, so you can deploy things, but not create a link on the website to download it yet, or not turn the feature on, etc. You can deploy, but not release. Speaking of which, I mentioned that I don't think it's continuous delivery if there's not a button you can push right now. And then I told you to do all the code on mainline or trunk. And so probably about half the people in the room said, wait, I don't write, my features take longer than a day. Okay, I can't write a feature in a day, so how can I push the trunk in a day? There are lots and lots of ways to do this. Okay, one of our favorite is a concept called feature toggles. So this screenshot and that link are from a blog article that again, Martin Fowler did many, many years ago. Basically, the idea is I have a new piece of work. So I have a user story, whatever your word for that is. I have a new piece of work. The first thing I do is write a configuration file that turns that piece of work off. And then as I write the code, I say, if on, display this. If not, then do the old thing. Okay, in that way, I can deploy the software. I could take this build and deploy it to production, but people can't actually see the feature yet, or it's not being executed yet, or the API is switched off, et cetera. There's lots of ways to do this. Now, interestingly, these toggles can be used for a lot more than just this. Okay, so this is a screenshot from another colleague, Pete Hodgson, that wrote this one, again, feature toggles, but this year. And it talks about some of the stuff that, that we also do with toggles. So we can have really advanced routers in there. So Facebook did a post in the last week or two where they talk about they've moved to trunk-based development. And one of the things they talk about is they have a thing called gatekeeper. That if something goes wrong, they can hit a panic button and it turns it off. That's done with things like toggle routers. Okay, so the feature comes on, they release a feature, first thing it does is go to their employees. And so there's a filter of some sort, I don't know how they actually implemented it, that said, if you're on this network, turn this feature on. If that works well for a little while, then it goes to a larger set and a larger set and a larger set. That's all done with toggles. But you can also have toggles for, again, other things. So I'm talking about release toggles. They're short-lived. Please clean them up. Okay, hint, not capital. Please clean them up. So it is tech debt. You must be aware that you are investing in tech debt. When you have released, you do want to go back in there and remove the toggles, et cetera. But there's other things you might want to leave in there. So operations toggles, permissions, et cetera. There's a lot of systems out there today in our world of SaaS where we do performance degradation. So one of the best examples is if you log into Netflix, it makes a bunch of recommendations about, here's movies you might like. If they're under extreme load, automatically that gets toggled off. You can still watch your movie, you can still see your playlist, you can still search for things, but the recommendation engine gets turned off. So they degrade performance automatically using things like toggles, instead of having the system go down and make it so you can't watch the movie. Now, often there's major changes we want to make. We want to make changes to an underlying component. Well, how the heck do I do that on trunk? There's another concept called branch by abstraction. So let's say we have an architecture and we have a component, and we have consumers of that component, and we want to replace the component. So one way you can do that is to create an abstraction and have it call the component. So far you've changed nothing functionally in the application. You created a bunch of code in there that's in there for no particular reason. But then you start swapping around. So you add the new thing, and slowly you start moving things over to call the new thing, until eventually you don't need the old thing anymore and it goes away. So we can do that. I mean, again, tech debt, please finish it. There's a lot of people that start this, they get halfway done, and now they're both in the system. Which again, might be okay if that's the right thing to do for your business, but be aware that's the thing to do. Okay, so now while you're doing all this thing, I also want you to encourage you to manage risk. It was interesting to have a conversation just at the table earlier, where I'm not going to drop the name see if I make eye contact with them. You made a comment. Hey, we have systems that they go down for a day or two, no big deal. Okay, but we have other systems that if it goes down for a minute or two, big deal. Okay, so be aware of that when you're doing these things. I'm a big fan of optimizing for recovery. So if you're not familiar with the Wikipedia definitions, mean time between failures and mean time to recover. If you're writing aircraft systems, please do mean time between failures. I fly roughly 150,000 miles a year. I really don't want to crash. But if you're creating cat memes, maybe not as much risk. So what you want to be able to do is you want to repair the system quickly. Another thing that actually led to this talk, if anybody's read the State of DevOps report, it's interesting. It's a thing that was done, surveyed 37,000 people. It's a good resource. You should read it, by the way, if you haven't. It's called the State of DevOps report. You can Google it. They track things. They call them high performers, low performers. I'm not crazy about the metric. The metric is how often you deploy. That said, the low performers are deploying more often this year, but their MTTR went up. So their metric was deploy more often, but they didn't have the test. They didn't have good CI. Okay, so be careful, but you want to go for yours. Okay, some patterns. And this is 2 of 973, okay? But some patterns that can help you manage this risk. So there's an idea of canary releases. Everybody's familiar with the canary in the coal mine. Take the canary in with you when you're going to mine coal. If it dies, leave. Because their lungs are smaller. Okay, so cruel, but that's where it comes from. So you can deploy, much like Facebook, the story I told a second ago, deploy to a percentage of your thing. Snapchat runs 1% of their traffic, their production traffic, on their development environment. So people's Snap might not go through, and they try again, and then it does go through, because now it's on the other 99%, okay? But they can catch things, and that's acceptable to them. I love this one. So dark launching, my favorite story is Facebook Messenger. So if you've ever used Facebook Messenger, you log in, you can type a message to your friends, they can answer, et cetera. How do you test that at their scale? I mean, I just said you have to do stress tests. How the heck do you do that? What they did is it was all toggled, and when the feature was, quote unquote done, it was released but hidden behind JavaScript. So when you logged into Facebook, it sent messages to X% of your friends. And when they logged in, their browser saw the message, and X% of them replied. And that went back and forth for months. We were all messaging each other, lorem ipsum, whatever, and we didn't know it. When it was time to launch it, they flicked the toggle that made the JavaScript go away, so now it was visible. No problem. Because we'd already been using it for months. And so you can test in production if you're at that scale. So do that. Feedback loops are always also very, very important. Please create useful logging. Failed is not useful. Okay, what actually happened? Couldn't make the SQL insert? Was there an error returned? I need these things there so I can quickly recover, right? As I mentioned, sometimes you need to run tests against production. That's cool. Not all of them maybe, but what the heck? Run your things through there. There's systems for that. And on the topic of usefulness, same with alerts. Okay, a lot of people say, when you go to a DevOps culture or you implement continuous delivery, one of the first things you do is give the developers pagers. I think at a high level that's a good idea. You make the person writing the thing responsible for the thing. But if you page me at 3 in the morning because something failed that really doesn't matter, I'm going to get really grumpy. Okay, so your alerts, and there's vendors out in the hall that can help you with this. We're not one of them. Need to be gone through a filter that says, okay, this thing that's going wrong is going to cost us money. We need to fix this, or we're going to have problems. Okay, make sure you're alerting on the right things. Because now if I'm deploying every day or many times a day or whatever your right thing is for your business, you need to know quickly if they fail, but only if it really matters. Okay, back to Knight Capital. So Knight Capital is a company that was doing a lot of the things that I just talked about. They were doing front-based development, they were doing feature toggles, they were doing all those things. And what they weren't doing is they didn't have a lot of good automated tests, and they weren't cleaning up their technical debt. And I don't mean to pick on people. I'm a big thing that root cause, root cause isn't a thing to begin with, but if it was, what we tend to do is we tend to go back and say, oh, person made a mistake. Okay, well, did person make a mistake because they had to work 80 hours this week? So what, okay. But at any rate, they reused the toggle from an obsolete function and manually then deployed it to 7 servers. Problem is they had 8. The idea of this function was to send a bunch of child orders out. And instead of faking it, what it was supposed to do, it was sending real orders. In 45 minutes, Knight Capital lost $440 million. Their market cap was 420. Gone. Somebody came in the next day, acquired the assets. I think the logo might still exist, but literally gone because they reused a feature toggle that didn't get deployed to the 8th server. It's all on Wikipedia, the details if you want to read it. I don't want to blame, again, the individuals, but the point is you need to be testing for these things. You need to have, is this toggle reused, is it, et cetera. And there's ways to do all that. So, summary. Automated build and test has been around for decades, okay? Don't call it CD if you don't have a button, okay? It's still good, but you don't have a button, okay? CI habits are absolutely prerequisites. So, I like feature toggles. That's me. Thank you for your time.